We'd like to welcome you to today's webinar, VMware Cloud on AWS, a technical deep dive, which is hosted by Amazon Web Services. My name is Andy Reedy. I lead this Partner Solutions Architecture team here at AWS, which is dedicated to VMware Cloud, and I'll be your host and speaker for today. I'd like to also introduce my colleagues Win Yu and Arthi Raju, who are both Partner Solutions Architects dedicated to the VMware Cloud and AWS service and the VMware relationship. With the introductions out of the way, we'll go ahead and dive right into this and start today's session. Okay, great. Here we go. So one of the things I want to start off talking about today are just a few of the scenarios and use cases that we see with VMware Cloud and AWS. The first scenario we really see this being applicable for is customers who are looking to maintain their existing on-premises environment, but are looking to expand into the cloud. Maybe they're looking for geo expansion, moving into a different region. They're looking for a disaster recovery option, maybe a backup facility. But they're ultimately looking to maintain those assets that they've already purchased and looking to expand into the cloud environment. In the second scenario we hear a lot about from customers is being able to consolidate and migrate. These are customers who are looking to consolidate the number of physical data centers they have down, or perhaps get out of the data center business altogether. And looking to migrate all of their existing VMware-based workloads into a cloud environment. The third scenario that we hear a lot about are workload flexibility. So these are customers who maybe they want to keep their on-premises environment, they need to flex workloads into the cloud or operate in a truly hybrid manner. You can think of things like ephemeral use cases such as temporary projects or production expansion for seasonal activity, cyclical type workloads. Perhaps development projects or training events, those types of things, but being able to burst that capacity into the cloud from their on-premises environment. We've talked about kind of some basic use cases, some ways that people are interested in using VMware Cloud and AWS, but specifically one of those use cases talked about bursting and being able to operate in a hybrid capacity. So wanted to talk about some of the things that we hear customers say that they want in a hybrid cloud environment. The first thing we hear is that they want to be able to continue to run workloads on premises. And they also want to be able to run workloads in the cloud, but they don't necessarily want this to be a binary decision. They don't want to have to choose, I want to run everything on-prem or everything in the cloud. I want to be able to do both. And by doing both, I also really want tight integration between those two environments. I want the platforms to be as seamless as possible so that I'm able to operate in both of these without a large amount of differences. And I'd like to be able to do all of this without buying new hardware, without having to make additional capital investments. We very rarely hear from people that they're looking to buy even more hardware or expand even further their physical on-premises environments with large capital investments. They'd like to be able to leverage the assets they have, continue to use those workloads or run workloads on premises. They'd like to be able to run workloads in the cloud. They'd like to have good integration between those two things, and they don't necessarily want to have to buy new hardware in order to do it. So if that's what we're hearing from customers as to what they want, why isn't everyone doing this? What are the challenges that we hear people are facing when trying to operate hybrid cloud architectures? So the first thing we hear a lot about is multiple machine formats. If you think about it, in your on-premises environment, you're running vSphere VMs. If you try to move those to the cloud, you're looking at a transformation effort. You're transferring from VMs to Amazon machine images. If you have templates, you have to build two sets of templates. Maintaining and updating those golden images, obviously takes effort on both sides. But this is a transformation effort. It's not a seamless migration to go between on-prem and into the cloud. Again, two separate platforms in that case. The second thing we hear a lot about is incongruent networks. So you have IP networks on-prem, you have IP networks in the cloud. These are separate IP networks. You can certainly route between them, but they're ultimately different subnets. If you were to move a workload between those two environments, you're looking at having to actually re-IP that workload. You have things like operational inconsistency. If your operations teams are like most, they have a lot of runbooks. They have processes and runbooks for things like provisioning and deprovisioning, responding to host failures, maybe security incidents, but they maintain a catalog of runbooks for their operational processes. When you have an on-prem environment and a cloud environment which are different, you ultimately have runbooks for each of those platforms that are separate and have to be maintained independently. You have things like skill sets and tooling. Just because you know vSphere doesn't necessarily mean that you know how to operate an AWS environment, and vice versa. Operating these platforms, there's differences between them, obviously. There's different approaches. So having to maintain skill sets and keep up to date on the latest and greatest in each platform. And then tooling. If you purchase software, if you purchase applications, third-party applications or off-the-shelf products, in order to manage or provide additional functionality for each of those platforms, you have tooling that you've invested in today, and that tooling isn't always compatible in both environments. And things like monitoring and control, thinking about auditing situations or going through and trying to validate user permissions. You have, in an on-prem environment, you have vSphere roles and access control there. In AWS, you have identity and access management, IAM, where you have roles and policies there as well. These things are often different. Having to keep track of who has permission in each system and each platform, and making sure that those are appropriate, it certainly takes effort. The common theme to all of this, all of these different things that I've listed off, is it's duplicate effort. You're doing one thing on-prem, you're doing another thing in the cloud, but you have different. You have to duplicate those efforts in order to keep both platforms into a state that you're happy with, or into the current operational state. Okay, so we've talked about some hybrid use cases. We've talked about challenges people experience with hybrid. Now I want to actually introduce VMware Cloud and AWS. For those of you who may not be as familiar with it, we can talk a little bit about what this is, how it actually works, and how it helps solve a lot of these problems that we've just talked about. So the first thing to know about VMware Cloud and AWS is that this is a service that is sold and supported by VMware. This is essentially a vSphere software-defined data center sold as a service. So there's really three main components to the software-defined data center. You have vSphere, you have vSAN, and you have NSX. So vSphere is vSphere. This is the same vSphere that you use in your on-premises environment. If you were to log into the vCenter interface for a VMware Cloud and AWS software-defined data center, this would look very much like the same interface you're accustomed to in your on-premises environment. vSAN is used as a storage layer. We'll actually talk a little bit more about that in a moment, but that's going to provide the actual distributed data store for workload use in the VMware Cloud and AWS environment. And NSX is going to provide the network virtualization and security, network security capabilities for VMware Cloud and AWS. Something that's been introduced as a part of vSphere 6.5 is what's called hybrid linked mode. So this essentially allows you to connect this VMware Cloud and AWS software-defined data center back to your on-premises environment. So if you think about, you have maybe an SSO domain set up in your on-prem environment, VMware Cloud and AWS comes pre-configured itself with its own SSO domain. Hybrid linked mode is going to allow you to connect those two together. So when you open up your vCenter environment on-prem, you will be able to see your software-defined data center in VMware Cloud just as another data center. So now you have that single pane of glass management where you can manage this environment just the same as you would your on-premises environments today. All of the VMware Cloud and AWS software-defined data center is running on top of AWS's global infrastructure. We'll talk a little bit more about that in a moment, but because it's running inside of an AWS region, you now have high bandwidth, low latency access into all of the native AWS services. So you can take advantage of things like Amazon's Redshift, or maybe running or storing objects inside of Amazon's S3, or using relational database services like RDS or NoSQL databases like DynamoDB. But ultimately, now you have high bandwidth, low latency access into all of these services. You can augment the workload that you're running inside of VMware Cloud and AWS and take advantage of these services as appropriate. So we talked about VMware Cloud and AWS being delivered as a service. There's a few things to note about this. So I mentioned AWS is running all of the physical resources. VMware is going to manage the hypervisor and all of the management components. So if you think about it, you no longer have to mess with the physical environment. That's taken care of by AWS. VMware is going to take care of the hypervisor, all the management stuff. So they're actually going to take responsibility for managing vSphere. So you're not going to deal with patching and updating and responding to issues within your virtualization stack. This really leaves you free to focus on running your workloads. So you don't have to manage the physical, the virtual. You really focus on running your workloads and your applications. So access to vCenter and VMware Cloud and AWS, there's a few different ways to do this. You go through a portal, so there'll be a VMware Cloud and AWS portal that you use to actually interface with the environment. But then when you want to actually manage vCenter itself, you're logging in through vCenter just as you would today. Because this is a service that's owned and operated by VMware, there are some restrictions, some things that you need to be aware of. First, you'll have no root access to the ESXi hosts themselves. You won't be able to do things like configure VDSs or change the underlying management network structure itself. And you'll have no direct access into things like the NSX edges or the underlying virtual appliances that are running the infrastructure itself. So you have delegated authority. There's an account called Cloud Admin. And Cloud Admin gives you permission to essentially go in and manage the workloads and do a lot of the NSX management. Do a lot of the management of the environment itself, but not necessarily to change the management infrastructure, which is running the service itself. Okay, so let's talk a little bit about what this actually looks like in the physical world. So the VMware Cloud and AWS environment has a minimum requirement of 4 hosts. So each one of these hosts is equivalent to an i3 16XL AWS instance size, if you're familiar with those. So you're going to have 36 cores, 512 gigs of RAM, and there's 15 terabytes of NVMe all-flash storage within these instances themselves. Now, I'll immediately caveat that saying not all 15 terabytes are usable for workloads. We'll talk about that more in just a moment. But this environment is completely pre-built and configured by VMware and handed to you whenever you provision the environment. So you do not have to configure ESXi, you do not have to configure vSphere. The environment is automatically built and configured for you by VMware, and you're essentially handed a vCenter endpoint that you can then log into and manage your workloads that way. ESXi is running natively on bare metal, so this is not nested virtualization. This is not any kind of virt-on-virt solution. This is VMware's running ESXi directly on these physical hosts in the AWS global infrastructure. As I mentioned before, we're using vSAN. So vSAN is taking that NVMe-backed storage and it's aggregating each one of the instance stores on these hosts. So that means a couple of different things. One is that storage is going to scale linearly with the number of hosts that you have in the environment. So if you need to add additional storage, you simply add an additional host to the cluster. If you shrink the number of hosts down, obviously the storage will go proportionally to the number of hosts you have in the environment. But vSAN is basically taking that very high performance storage and aggregating that and delivering a distributed data store in which you can run your workloads. NSX is creating the network virtualization layer, so the actual overlay networks. So within NSX, you can create logical networks. If you're familiar with NSX on-prem, you have the ability to create logical switches and logical networks. So within the VMware Cloud and AWS environment, you can create logical networks. And you can create multiple networks, and they'll all be connected up in through what's called a compute gateway. So the compute gateway is essentially that gateway device is going to provide access out from the virtualization layer out to the internet itself. There's 2 gateways involved here, so 2 different network stacks, if you will, or network segments that are provisioned by default. You have your compute environment and your management environment. So the management gateway will exist to provide connectivity for things like vCenter, all of the actual management components that are running the stack itself. And the compute gateway is provided to provide a gateway access for all of your VM workloads. So as you create new logical networks, those will all be plumbed up automatically through the compute gateway for access out to the internet. Likewise, if you're wanting to build connectivity into these environments, we'll talk a little bit about that later, but that's where you would actually terminate your IPsec tunnels is into these gateway devices, both the management gateway and the compute gateway. So as I mentioned, this is completely supported by VMware as a cloud service. So VMware is going to take care of things like patching and updating and upgrading these virtualization components. So there's no longer a need for you to focus on dealing with compatibility guides, or is this version of ESXi compatible with this version of vSAN, or do I need to be running this version of vSphere for NSX to be running? All of that is taken care of by VMware. So they will take care of patching, updating, and upgrading the environment. When you go to provision new hosts in the environment, VMware will automatically provision those hosts, join them into the cluster, and they'll be available to you to run new workloads. So that gives you the ability to scale up and scale down dynamically, which is something that really has been a little more challenging in an on-prem environment. If you think in your on-prem environment, if you were to try to add hosts to a cluster, you're normally going through a purchasing process. You're waiting a few weeks to get hardware to show up. You're racking and stacking, cabling, burning in, deploying the actual software, then joining it to the environment. That can take an order of weeks to potentially months. In this environment, you simply can log into the VMware Cloud and AWS console. You can click a button to add a host. The host will be joined to the cluster automatically, and typically takes in the low double-digit number of minutes, so say 10 to 15 minutes to add a host to a cluster, which is just a drastic difference compared to the on-prem world where you're waiting weeks to months. I mentioned briefly the connectivity options for connecting in from your on-prem environment, and just to elaborate a little bit on that. So if you think about it, you have your customer data centers, you're running your vSphere environments there today, and then you deploy this new VMware Cloud on AWS software-defined data center. So how do you actually connect these two environments together? How does this connectivity actually work? So today, the capability options that you can do are IPsec VPN. So this allows you to build an IPsec tunnel from your on-premises network devices today into the compute gateway and management gateway of VMware Cloud on AWS. So this allows you to have that layer 3 connectivity. You can now route between these two environments. An option that's in development for VMware Cloud and AWS is L2 VPN. So this would actually allow you to stretch a layer 2 network between your on-prem environment and the VMware Cloud and AWS environment. Also, a feature that's in development is the ability to leverage Direct Connect. So if you want to be able to have a private connection into the VMware Cloud and AWS environment, you'd be able to leverage Direct Connect, essentially a private connection, which is going to kind of bypass the internet weather. So if you're looking for more consistent latency or a particular bandwidth, you could achieve that with Direct Connect. So also, if you're an AWS customer today, then you would have your customer data center, and you would have your actual customer-owned AWS account. And so this is the account that is owned by you, the customer, and you would want to connect that back to your customer data center. So a couple of options there, very similar to what we just talked about. You could use IPsec VPN to connect into your AWS environment, and you could leverage Direct Connect for connectivity there as well. So now, what if you want to actually be able to connect your VMware Cloud and AWS SDDC into your customer-owned AWS account? We talked about that earlier. What if you want to leverage things like Redshift or S3, and you want to be able to have your VMware VMs that are running inside of your SDDC take advantage of those services? So there's a couple of things to keep in mind there. By default, whenever you provision this environment, you'll be prompted to connect it back to your customer-owned AWS environment. When you do that, AWS will actually deploy some ENIs inside of your customer-owned AWS account. And these ENIs will be connected back into the compute gateway from your SDDC. So you can think of this very similar to how RDS works today, if you're familiar with that. When you go deploy an RDS instance, you don't actually see the servers or the instances themselves pop up in your AWS account. What you see is an ENI show up on a subnet, and you have an IP address that you can then use to communicate with RDS. So this is quite a similar approach. In this case, whenever you connect these two environments together, an ENI or several ENIs will be provisioned into your AWS account, and these ENIs will be used to provide connectivity over into the compute gateway of your VMware Cloud and AWS SDDC. So this allows you connectivity between your instances running in AWS or any of the services that you have in AWS and the VMware VMs running inside of your SDDC. And we'll talk a little bit more about this in detail as we go along. So we have a scenario here where we have a customer data center, and we'll highlight kind of the L2 VPN option that I talked about from an on-prem into the SDDC, and we'll talk about the connecting a customer data center back through VMware Cloud and AWS through IPsec VPN. So in the first scenario, you have a customer data center, number one, on the left, and they would like to be able to connect into an SDDC that they've deployed in VMware Cloud and AWS. So in this case, again, this functionality is something that's in development, You'd be able to deploy a bespoke NSX Edge on-prem and can use that NSX Edge to establish a layer 2 VPN connection back to the compute gateway in your VMware Cloud on AWS SDDC. So this would allow you to have layer 2 connectivity between your on-prem environment and your VMware Cloud on AWS SDDC. And the second use case, so let's say customer data center number 2, a separate team, perhaps a different business unit within your organization. They want to provide just basic layer 3. They're not necessarily interested in being able to stretch layer 2 connectivity. So they would be able to actually establish an IPsec VPN connection into the CGW of VMware Cloud and AWS, their SDDC itself. So it's important to note this VPN connection is not terminating to underlying AWS infrastructure. This is not going through like a VGW or a typical AWS VPC connection. You're actually terminating this IPsec connectivity directly into the CGW, which is then going to provide access to that overlay network. So we mentioned that integration using those ENIs, and this is a little more detailed view of that to give you a sense of what this would look like. So on the left-hand side, you have an account which is owned and operated by VMware. So this account is what is actually going to house the VMware Cloud and AWS resources. This is not an account you can log into or have visibility to. Essentially, VMware creates this on your behalf, and they use this account to deploy the ESXi host and actually run the infrastructure for you. So this is not a shared account with multiple tenants. It is a dedicated account to you as a customer that they operate on your behalf that houses all of these resources. And on the right-hand side, you have your customer-owned AWS account. So this is where you would run things like Amazon's Redshift or DynamoDB or EC2 instances, those types of things. So two separate accounts, one owned by you, the customer, and one owned by VMware, where they're going to run these resources. So as we mentioned, we can create these logical networks inside of the SDDC. So in this case, we have a logical network 172.31.1.0/24. We have a couple of VMs running inside of this environment. And this logical network's default gateway is the compute gateway, which is that NSX Edge device that's running in the environment. And that compute gateway has connectivity back over into your customer-owned AWS account via the ENIs we talked about earlier. So in this case, if I'm a VM running on that logical network and I want to connect back to an EC2 instance, for example, running in that VPC subnet 10.1.1.0/24, I can do that. It's private connectivity. There's no VPN connections or direct connect or anything like that. The connectivity flows through the CGW, and the CGW has routes to get to that subnet via that ENI. So if you think about it, now you can have VMs running inside of this SDDC, which are able to seamlessly take advantage of all of these AWS services that you have running inside of your customer-owned AWS account. So let's put this all together. So you have your on-prem environment, you have this SDDC, you have resources running inside of your AWS account. How could this all fit together from an application perspective? So first, let's say that we have an e-commerce application, or we're an e-commerce company, and we have a web front end that we use to serve our customers. We have database backends. We have fulfillment centers where we have local resources. So in this case, we could say, hey, we want to put our web front ends inside of the AWS environment. This allows us to take advantage of things like Route 53. We could leverage Elastic Load Balancer with EC2 instances that auto-scale. That's a very common use case in an AWS environment. But we don't want to have we don't want to leave behind the vSphere environment that we know and love. We want to continue to operate as many of these workloads as possible using our vSphere environment. We don't want to transform and move these into AWS. In this case, we can spin up a VMware Cloud and AWS software-defined data center, and we can seamlessly move our workloads into this environment. So we don't have to go through a transformation process. We can continue to use vSphere, and all the tooling and all the run books and processes that we have in place, all of that is still very applicable. We don't have to change how we're operating this environment. But we can move this out of a data center into an environment that we can scale up and down dynamically, and we get the advantages of being co-resident in the same environment where all of the AWS cloud services are running. So we have low latency access between these web servers running in AWS and our application and database services running in VMware Cloud. And that's a very seamless and easy connection without a whole lot of effort on our part. And then we have these regional fulfillment centers. Maybe we have local workloads there that we need to be able to keep on site for latency reasons, or maybe there's a geographic requirements that force it to be in that local area. And we want to keep some local workloads and databases running in that environment. But we do have situations, maybe there's a holiday burst or a particular time of year that's very busy. We do have times of year that we want to be able to burst those workloads and expand that capability without necessarily having to buy new hardware on-prem. So in that case, we can actually run our application and database servers in VMware Cloud, and we can do burst capacity from our regional centers into the same VMware Cloud on AWS environment. So use that as kind of an overflow, if you will, for capacity. But now that we've been able to move our back office and billing systems and all of these commercial off-the-shelf products that we use in our enterprise environment into VMware Cloud, we now have some other interesting opportunities. We could easily take advantage of things like Amazon's Redshift or even maybe Amazon's machine learning capabilities. All of these, again, are running in the same geographic footprint as our resources running in VMware Cloud and AWS. So that allows us to take advantage of these services and perhaps do things that we couldn't do on-prem or that were maybe too latency sensitive to do when these workloads were running on-prem. But this hopefully gives you a flavor of how you could actually take a service and you could take advantage of the best of each one of the things that the platform has to offer. You can use AWS for web front ends or whatever really, if there's a particular service or anything there that would be useful for you, you could take advantage of that, but you don't necessarily have to. In the VMware Cloud and AWS environment, you can run your workloads there, you can expand your workloads there, but you don't have to change your tooling, you don't have to change your processes. You can continue to use the same vSphere software that you know and love today. So let's kind of put all this together from kind of a value perspective to understand all the different benefits that this really gives you and how this stacks up, if you will. So the first one is on the physical infrastructure side. When you're running a software-defined data center in VMware Cloud and AWS, you're no longer dealing with power and cooling, physical security, ordering cross-connects. Do I need to expand a cage in this environment? Have I done all my inspection on my fire suppression equipment? All of that stuff essentially goes away. AWS takes care of all of the physical infrastructure. VMware is going to take care of the entire virtualization stack in this environment. Again, this is a supported service from VMware. It's vSphere as a service. So they're going to take care of patching ESXi. They're going to take care of patching vCenter, upgrading these environments, responding to host failures, provisioning new hosts in the environment or deprovisioning hosts in the environment. Your interaction with this is through the VMware Cloud and AWS console, which Win is going to actually demonstrate in just a few minutes. So you'll get a sense of what that actually looks like. But you're now clicking buttons or using an API as opposed to having to unbox servers or patch software or respond to host failures in the middle of the night. That's all taken care of for you as a part of the service. Now you have the workload flexibility. If you think about it, because you're running vSphere on-prem and you're running vSphere in the cloud, you now have an extreme amount of flexibility to move workloads wherever it makes sense for you. There's absolutely going to be use cases where maybe it makes more sense to use or to run this particular workload on-prem, and you can do that. But if you need to move that workload or burst that workload into the cloud, you can easily do that without having to go through a transformation effort. Whenever we have the L2 functionality, you can do that without having to re-IP the workload. All of that becomes very seamless to be able to migrate a workload between these two vSphere environments. You can think of it very similar to today. If you have multiple vSphere environments today and you're doing migrations between vSphere environments on-prem, it's a very similar approach to that, where you can easily move a workload between your vSphere environment on-prem and VMware Cloud and AWS without having to go through any type of transformation or replatforming effort. Then you have elasticity. So you can easily scale up or down these environments. And if you think about it, this is something that really is not easily possible in an on-prem environment today. To be able to click a button and add a host to a cluster and have it appear in the low double-digit number of minutes, this is extremely powerful and actually will change the paradigm of how you think about capacity planning. If you're like most organizations doing capacity planning today, you'll operate vSphere clusters somewhere in the neighborhood of 40 or 50% utilization. And you do that because you need to have additional headroom or additional capacity available to account for host failures. Or you need additional capacity available so that if you have bursty workloads or you need to add additional hosts, you don't necessarily want to have to buy new hardware every time you need to add a new VM. In this case, since a new host is available very quickly in the low double-digit number of minutes, you can click a button and add a host. Maybe now you can operate these clusters at a much higher utilization. We're certainly hearing from a lot of customers that that they feel comfortable running their clusters at a much higher utilization because they know they can click a button and replace a host, or click a button and add a new host to the cluster, and it's not going to take weeks or months to get that additional capacity. So this really changes your TCO calculations of how you think about the TCO of your environment, because you're able to use maybe 70, 80, 90% of the environment depending on your tolerance, as opposed to 40 or 50%, ultimately because that you can replace that hardware or add new capacity in your environment very, very quickly. And then from a cost perspective, we hear a lot of customers tell us that they will bundle large CapEx costs. In order to try to drive discounts with hardware vendors, they'll wait and they'll buy a large pool of hardware at once, and then they'll kind of burn through that hardware throughout the year, and then they'll get to another point where they need to buy another batch of hardware and kind of burn through that capacity. So it's a very large capital purchase, and then a slow usage of that over time to kind of grow into that usage. In this case, you pay for what you need when you need it, and then you give it back if you don't need it anymore. So you go from a CapEx model to an OpEx model, and the variable expense is often quite cheaper than what you could do on-prem due to the economies of scale from an AWS environment. And then the ability to expand globally. We didn't talk about this directly, but today the service is available in our US West Oregon region. The VMware has announced that they'll be deploying the service in US East Virginia later this year, and then London early in 2018. But as they continue to add regions to the service, now you have the ability to actually deploy an entire software-defined data center with the click of a button in a new region. So you can deploy new data centers through the console, through the API, and you're not dealing with vendors in different countries or customs or going through any type of import-export processes to build new facilities in different regions. You can do all of that electronically through the console, and VMware will dynamically deploy this environment for you. And lastly, you're running inside of AWS's global infrastructure, so now you have high bandwidth, low latency access into all of these AWS services. So you can augment your existing workloads or expand the capabilities of your existing applications by taking advantage of maybe data warehousing or object storage, any type of Amazon machine learning, those types of things. But you now have access to this large catalog of services that you can use to then augment and expand the capabilities of your applications today. Okay, so with that, hopefully it gives you a good sense of kind of the basics of VMware Cloud and AWS, some of the benefits and use cases. What I want to do now is hand it over to Wen Yu, and Wen is going to walk us through a couple of demos which actually show you what this looks like in real life and get a chance to see the environment function. Wen, over to you.
Thank you, Andy. Hi, folks. There are two demos we want to showcase today. The first of which is a quick walkthrough of the VMware Cloud on AWS Web Portal. That's a portal that you will have access to as a customer once you get onboarded to the service. In there, you have the ability to perform some simple workflows such as creating a host, like Andy mentioned, removing a host, or add additional SDDC cluster to the region of your choice. And then once we get through with that, we'll then walk through a quick demonstration of how you could go a step further and take advantage of the native AWS services to protect your web internet-facing application. With that said, let's quickly walk through the VMware Cloud on AWS Web Portal. As you can see here, this is the portal that you would have access to as a customer of this service. And in here, we have a SDDC cluster that's been provisioned in the Oregon region. And in here, you have a quick glance of the CPU, memory, and storage utilization of your environment. And some of the simple actions that you could perform are the following. For example, you could add a host to the cluster. Like Andy mentioned, you could dynamically add hosts on demand, and it takes low double-digit minutes to get a host added to the cluster. As you could see here, you just select the number of hosts you want added, and you click Add Host, and it provisions right away. And it's not just a vanilla ESX installation with the software and binary and such. It actually has ESX along with the necessary components for NSX as well as the vSAN disk group, so the host can immediately contribute to compute and storage resources to the cluster. And you could easily perform a remove host operation as well, as you can see here. And this really gives you the full benefit of resource elasticity of the public cloud. Okay, so as easy as that sounds, let's take a look at the connection information that is available to you as a customer. And here, what you see is the vCenter server endpoint that you could use to do one of two things. For example, if you want to use the hybrid link mode to connect the vCenter server on premises to the VMware Cloud instance vCenter, you could do that. Or you could simply log into the web interface like we will do in a few minutes here. And with that, let's quickly look into the network representation of the service. You can see there are two gateways here. Like Andy mentioned earlier, there's the management gateway that allows you to have a layer 3 IPsec VPN tunnel into the management network where vCenter server resides. So you could do the hybrid link mode, as well as the compute gateway, which is a gateway that allows you to have IPsec VPN connection to the virtual machine logical networks that have been provisioned in VMware Cloud on AWS. And if you scroll down here, you have the ability to have single pane of glass view of all the firewall rules that you can configure for each of the two gateways. And the compute gateway in particular is one that you could create the logical networks, and then the firewall rules that control the traffic flow between logical networks, as well as from logical networks to the connected Amazon VPC. And you could do simple NATing by requesting for a public IP address and associate that with the private network IP for the virtual machines. And you could have VPN established here with a simple click of buttons. And I do want to draw your attention to the logical representation of what Andy mentioned earlier, which is the connected Amazon VPC. So this is a logical representation of the high bandwidth, low latency link between the SDDC cluster and the Amazon VPC. It's a connection that's private and that allows for virtual machine connectivity from SDDC into native AWS services. Okay, so what we'll do as part of the demonstration is we'll do a quick creation of a logical network by logging into vCenter server, at which point we quickly browse through vCenter server and then create a logical network for us to connect into the Amazon VPC. So let's do that quickly here. Okay, so this is the cloud admin credentials that you could copy and paste into the new HTML5 client for vCenter server. Okay, so let's log in quickly here. Okay, so we won't spend a whole lot of time walking through the vSphere environment. I'm sure a lot of you are very familiar with this interface. So quick browse through, we have virtual machines running here on ESX that runs on top of bare metal EC2 instances. And then we have the storage provided by vSAN, like Andy mentioned earlier. There are two data stores. The vSAN data store is one that is the repository for the virtual machines that are serving the infrastructure needs, such as vCenter server, NSX manager, and the necessary virtual appliances. And the workload data store is one that you could place your virtual machines onto. You don't have to worry about hardware compatibility or certification or anything in that nature. You simply create a storage policy and you allow your virtual machines to be deployed in that data store. Now, in terms of networking, there is a DVS, distributed virtual switch, that allows us to create logical networks. Let's get into that. If you go into global inventory lists, this is where all the logical networks are represented as well as created. So we have a number of them in our environment. Let's quickly create a simple one. Let's give it a logical network as the name. And all you have to do is specify a CIDR block for the IP address range. Okay, so let's do a 15.0/24, and we want to have DHCP enabled by default, and that's a simple click of a button away. Now, logical network is created successfully in the environment. Now, let's take a look at how we could have that connected with the Amazon VPC. Okay, through here, there's a simple workflow that allows you to create a firewall rule that will allow for traffic to flow from the newly created logical network into the VPC through the ENI. Okay, so let's scroll down here and add a rule. And let's keep it simple and call it cross VPC. As the name suggests, we're doing exactly that. Okay, so this will allow us to have traffic from this newly created logical network. So the source will be our newly created logical network, and then the destination will be the connected VPC, and we do want to allow all traffic to go through. Okay, and as easy as that, you now allow traffic from logical network to the AWS customer account VPC side. Now, the reciprocal rule can be created. Okay, so you can just do a similar one and say in the other direction as an example. Okay, and the source will be the connected Amazon VPC, and then the destination, of course, is our newly created 192.168.15.0/24, and we all want to allow any sort of traffic. Okay, as simple as that. You have configured the firewall rules needed from the SDDC side. Now let's go into the AWS console quickly to make sure a route table actually has the rule that we created on the SDDC side for the logical network. So let's go into the route table quickly in the AWS console. And in here, we can quickly showcase, okay, so there's a list of destination. As you can see, there is the 172, which is the local VPC side of block, and 192 is our logical network, if you recall. And the target that it goes through for the connectivity is the ENI, like Andy mentioned. Okay, so we have added a new logical network. So let's get that added to the list here in the route table. Okay, let's get our ENI and simply select that from the list and off we go. Okay, actually we don't want to create another route, so let's close that one out, click save, and off you go. And as simple as that, we have now established the logical network that we just created to have high throughput, high bandwidth, low latency access to native AWS services. And with that, let me take you to a step further, which is a demonstration of how you could take advantage of native AWS services to secure your internet-facing application. So I do want to draw your attention to this architecture here before we get into it. So this is the VMware Cloud and AWS solution. In the middle connection here is the Elastic Network Interface that provides the connectivity, the private connectivity between SDDC and native AWS services. And what we have built here is a simple multi-tier web application, a WordPress application, okay, that we have migrated on premises without doing any sort of lifting or shifting, changing of VMDK formats, none of those things. We simply did a simple code migration from vCenter on premises into VMware Cloud and AWS. And from that point, oftentimes we get questions from customers. How do we go about leveraging your native AWS services to secure our internet-facing application? Well, the answer is the following. You could take advantage of these services seamlessly through this architecture. Let's walk through them. We could start with Route 53, which is our DNS as a service. We could integrate that with CloudFront, which is our global content distribution service. And then we have also the application load balancer that is a load balancer in the Elastic Load Balancing Service family. And the application load balancer will be configured to route traffic and distribute traffic across the web server virtual machines running SDDC. So that's the first portion on how we could leverage Route 53 coupled with CloudFront with integrated web application firewall, as well as AWS Shield coupled with application load balancer to provide layers of security protection for your web application. And then the second portion is how you could have end-to-end security visibility and control of all the web traffic that's accessing your application through a built-in analytics service. Okay, so the list of services that we will demonstrate are Amazon S3 for central repository of all the application access logs, as well as CloudTrail, which has active monitoring of all of the API calls to various AWS services, and how we could ingest those centrally stored data in Amazon Kinesis Firehose to ingest the data into a Elasticsearch cluster, and then couple that with Kibana, so you can have the visualization of all the traffic types. Okay, with that quick overview, let's jump into the actual demonstration of how you could couple these services, starting with CloudFront. So I mentioned earlier, CloudFront is the global content distribution service that we have. With CloudFront, a few things I want to call out here is we deploy CloudFront to use all the edge locations worldwide. So we have total of 98 edge locations worldwide, 87 of which are the point of presence locations, with the 11 other being the edge cache. Okay, so as a best practice, we recommend customers to put CloudFront to host your static, dynamic web contents, let it be static websites or dynamic websites or applications with client-side JavaScripting. Those could all be funded with Amazon S3 coupled with CloudFront. Okay, in here, and we do have the deployment to all edge locations. Okay, and then I mentioned the Web Application Firewall is another service that's deeply integrated with CloudFront to provide active traffic monitoring as well as enforcement. We'll get into the configuration of that in a little bit. Okay, so it's integrated with a WAF that we have created to work with CloudFront. And the thing with CloudFront is based on the security practice, we recommend customers to deploy CloudFront, so that could act as the first line of defense for your applications. So with CloudFront, you have the ability to control the traffic that gets forwarded to the origin. And with origin, you do have a lot of flexibilities here. And the origin that we have chosen to front the web server application is the application load balancer in the ELB family of services. Okay, and as you can see, we have the origin protocol that we could configure and support various traffic types. So we could restrict it to specific versions of SSL or TLS, as you could see here, as well as just restrict the traffic type to only HTTPS traffic from CloudFront into the origin, which is the application load balancer, giving you a way to secure traffic before they even enter into your VPC, and also give you the ability to accept only the well-formed web traffic. Okay, so that's CloudFront in a nutshell. Let's get into Route 53. So after you created the CloudFront distribution, you could easily integrate that into Route 53 in your hosted zone that has the DNS name record for your application. So in here, we'll get into the hosted zone for our application here. And I'll show you quickly how simple that is to have Route 53 tie-in with CloudFront distribution. So let's scroll down to the application of interest here. So what we're interested in is the Demo 1 App 2. This is the web application that we have migrated on premises. And in here, notice the name is alias to a CloudFront distribution. So after you created the CloudFront distribution, you go into Route 53. So what you do is you just have it populate as an alias target. As you can see, if you're a customer that is not quite ready to use CloudFront yet, you could easily use the ELB as an example as the origin that couples with CloudFront to front your web applications. Okay, so we're not going to make that change here, but I do want to illustrate how simple that is for you to tie it with the CloudFront from Route 53. Okay, next up, I mentioned the Web Application Firewall, WAF service, and AWS Shield deeply integrated with CloudFront and Route 53. So in here, Web Application Firewall is a service, it's a managed service that we have that provides active traffic monitoring of the web traffic and give you the ability to create dynamic firewall rules, right, on how you could accept traffic that's been matched with specific patterns that you have created as rules. So we have one that's created to work with CloudFront, so we could monitor all the traffic that's coming in. So as you can see, once you log into the service, you have an immediate glance of the 5-minute interval traffic pattern. Okay, so in here you do have the ability to choose the traffic that's been allowed based on pattern matching, as well as traffic that's been blocked, as well as the default action. So you could simply click into this buttons here, and it will reflect the traffic patterns that's been observed by the application firewall. Okay, with that, let's quickly walk into the rules that you could create. So in here, we do have a lot of flexibility for you to have control and do pattern matching to guard against common web exploits, such as SQL injection or cross-site scripting. So in here, you could just simply click into the blacklist rule. As traffic patterns change, you could update your blacklist or whitelist rules using the AWS console like I'm showing you here, or through the APIs. Okay, so you could quickly do that. Okay, so let's click into SQL injection. So these are the patterns that you could create and update over time. And for cross-site scripting, same thing. So with that, I would like to draw your attention to the AWS Shield, which is our managed service that provides resiliency against DDoS attacks. Okay, so all customers are able to use the Shield basic tier of service free of charge. So it protects CloudFront distribution as well as Route 53 as shown here. And there's the advanced tier that allows you to have 2 additional benefits, one of which is the ability to have 24/7 access to a team of security experts, the DDoS response team. So the team could help you create firewall rules that you could put into the web application firewall based on newly detected, advanced, sophisticated DDoS attacks. You could do that. And the second advantage is Route 53, CloudFront, as well as the ALBs. They all could scale elastically to accommodate DDoS attacks. So if the resources scale horizontally to absorb the attack to keep your applications available, then with Shield Advanced, you are not responsible for the increase of AWS builds. So you have an additional layer of protection with a peace of mind. Okay, so that's AWS Shield. Again, the basic version is available to all customers free of charge to mitigate against DDoS attacks. Okay, so we mentioned the traffic flow from Route 53 to CloudFront, protected and monitored by the WAF and Shield. And if the traffic is a well-formed web traffic request, a genuine one, it will get forwarded to the backend load balancer, which is the application load balancer. So to get into that, let's quickly take a look at it. Okay, so this is what we have in the application load balancer. And in here, we have listeners that we have configured to listen for the application requests. Okay, so in here, we'll throw into the rules. So the application of interest is this one that we have highlighted. And the forwarding rule is to a target group. So target group is a new feature that we have added to support instances that are not native EC2 instances. So in this example here, we have the target group representing the WordPress application that we have. Okay, so listed, these are all the web servers that we have running in the SDDC cluster. So as traffic comes in, it will get distributed across these virtual machines running as DDC. So just to show you that in action, so we have the web application being accessed here. So we configure this WordPress site in such a way that the traffic access could be reflected, and whichever server it hits, it gets updated. So if we hit refresh, for example, then it will get reflected here. Okay, so you can see the IP address change from 15 to 14 to 13. So all of which are part of the target group that I showed you earlier. Okay. And as simple as that. And there's one more thing I want to show you, that is the certificate manager. So if you have a lot of virtual machines that are internet-facing web servers, you could easily offload the SSL management to us. So we could take the undifferentiated heavy lifting off your shoulder. So you could import the SSL certificate that you have created and signed, or you could request one from us. And once that's issued, then you could easily install that into your load balancer, as I'm showing you here. So you could do a complete SSL offloading, not having to worry about the SSL creation, getting assigned, as well as getting it renewed. So you just click into the load balancer of interest, you add another listener, and you specify the protocol of interest, okay, HTTPS as shown here. And you simply select the certificate that you want to import from the certificate manager, ACM. Okay, so this is as simple as it gets. That's what we can do easily, leveraging native services. And with that, let's quickly showcase how you could have end-to-end application traffic visibility in this infrastructure. Starting with Kinesis Firehose that will ingest the centrally stored application traffic data into various endpoints, one of which could be S3 delivery stream. It could be a delivery stream into Amazon Redshift, which is a data warehousing service, like Andy mentioned earlier. And we also have what we will showcase here is an Elasticsearch cluster that will build indices of the various traffic types of the various services. Okay, so we could have easy analysis of how my application is being accessed globally. So these are the delivery streams into the Elasticsearch cluster in which index is getting built. So let's log into Elasticsearch itself to showcase how that's constructed from that service. So as a customer, like every service that we have, you don't have to worry about the underlying infrastructure. You simply create the cluster, give it an endpoint, and then start ingesting data with the Elasticsearch. And this is one that we have built for this application. So you could log into the cluster here and show all the indices that have been built with the various Kinesis Firehose streams. Okay, so with that, we could quickly have some visualization on all these data that we have accumulated and centrally stored. Right? Kibana is typically coupled with Elasticsearch to provide a web graphical representation of your data. So in here, this is all the index that's available for you to choose and have visualization. So let's pick one of, let's say, destination IP as an example. So we click destination IP, click visualize. You have the ability to have a quick glance at, okay, the traffic breakdown between the various target IPs and the count. Okay. Now, if we are interested in something else, for example, let's say we want to look at the security groups, for example, then we could do that as well. Okay, so this is security groups. Do a quick breakdown. So as you can see, it's a very simple point and click, and you have immediate visualization. Okay, and for the last few minutes of the demo, let me just quickly show you a graphical representation of, let's say, a heat map of the traffic that's hitting your application across the globe. So it's one of my favorite graphs to represent my web application traffic. So this is a global map of traffic access to your application. So you could easily do a search based on the traffic type of interest, let's say VPC flow logs, and for the destination port of 80, what's the traffic access pattern look like? So at a glance, this is what it looks like. If we change the action to drill down a bit more, let's say what traffic's been accepted, that's the accepted traffic. Now, accept, of course, there's the opposite, which is reject, right? You just click onto it here and change the port to 443, you get immediate visualization of what traffic looks like, and you could mouse over and drill down if necessary. Okay, so let's do another interesting one, which is, let's do accept, and let's do one more on CloudTrail. I mentioned CloudTrail is the service that audits the API request to various services. So this is an interesting one where you could track the log into the AWS console at a quick glance. If you have teams that are only in the US East, that's good. Right? Everyone's accessing the console from US East. And if you have a distributed team, then you might get traffic from elsewhere. Okay, as simple as that, you have immediate visualization of your application infrastructure. Okay, so all of these are services that you could just consume if you need them. Okay, and there's no software to install, no software to maintain. Like Andy mentioned, all the lifecycle management of the service with VMware Cloud and AWS coupled with native AWS services have a common theme: is you don't have to worry about any of these undifferentiated heavy lifting, right? And instead, you can focus on your applications. So with that, that's a quick wrap for the demo. I want to pass control back to the moderator so we could get into the Q&A.
Great, thanks, Wayne. Real quick, everyone, if you do have questions, please feel free to enter those into the questions pane on the right-hand side. We don't have but just a few questions here, so this will go fairly quickly. So I'd like to introduce Arthi, who's going to come in and answer some of these questions for us. So Arthi, the first question we have is, can you explain a little bit more about the replication and failover, failback for DR. Talk a little bit more about DR scenarios with VMware Cloud and AWS.
Sure. So DR as a service is currently something that's a roadmap feature for VMware Cloud on AWS. For backup scenarios, customers today can definitely back up their VMs to S3 using partner solutions such as Commvault, and then restore these VMs into VMware environments from the S3 backup.
Great. So another question that came in is about installing patches and updates. Questions around what is the update process? Will customers experience any downtime? Can you talk a little bit more about how patching and updates are managed in the environment?
Sure. So in terms of patching and updating, so the way VMware will do it today, so this is completely done by VMware. So VMware will add an extra node to the cluster for patching, so that from a customer's perspective, there's no downtime, and they remotion VMs into the new node that was added. And assuming there's failures that are detected by VMware, they proactively add this node before the failure happens, and then remotion all the VMs into the new node from the bad node. So from a customer's perspective, there's no downtime when this happens.
Great. And then the last question was around consumption and pricing. Are there multiple consumption options, and how is the service priced?
Yeah. So there's multiple consumption of offerings with this product. So you would see it is similar to AWS's pricing model as well. So VMware has an hourly pricing model. So the nodes are priced at an hourly rate. And there's also a 1-year and a 3-year reserved consumption model that is available. And the pricing details are all available on VMware's cloud.vmware.com webpage.
Great. Thanks, Arti. So we're going to wrap things up. Just some next steps for you that we would certainly recommend you check out. VMware has a great hands-on lab on their website. If you would like to check that out, that gives you an opportunity to actually get hands-on with the VMware Cloud and AWS console. There's also several breakout sessions which are going to be held at reInvent, which will have details of VMware Cloud and AWS, some deep dives and different things that may be interesting to you there. And then there's AWS webinars that will be going on as well, in addition to the one that you just attended. And we would certainly encourage you to check out these additional resources if you're interested to learn more about VMware Cloud and AWS. With that, we'll go ahead and close the webinar. Thank you, everyone, for attending. We certainly appreciate your time today and hope you found this event useful.